Hello, this is day 2 of pre-calculus. So go ahead and take your books out to page 402. We're going to go ahead and begin and continue the lesson. We will probably finish 5.1 by tomorrow and you'll have that all set. You can continue working on all your assignments. Then for today, I recommend you doing half of the homework assignment that was assigned for today, for Thursday, and the other half on Friday. So then you can get knowledge of both, because I believe there's like 4 or 5 problems at the very end that it will apply for tomorrow's lesson. So over here, if we look at this chart, and of course you need your unit circle, make sure you have that out because this is going to be your best friend. So all of these numbers are pertaining to something within here. So example 4A. So we're going to do 2 examples today, so 4 and 5. So example 4 and A. Example 4 tells us to find the terminal points. The terminal points, it's simply the coordinates you see on the side. So any one of those that you see on the side are considered the terminal points. So now, we go ahead and try to find the terminal points. So they show us an example. You see there's about 2-page worth of just different example of how to find the terminal point. One thing is, if you don't like radians, I'm not a big fan of radians, but if you really dislike radians, there's a way to make the radians and convert them into degrees. In your calculator, it does have a degree in radians button. So let's just say we're going to put this all in terms of degrees so it can make more sense, because the unit circle is from 0 to 360. So now, if you look here, it says radians over 4. Another way we can turn that into degrees is 180. Radians always means 180. So if you want to convert, just keep in mind that radians is 180. So that means 180 divided by 4, and that means your degrees is 45 degrees. So if you look here in your chart, right there, 45 degrees is radical 2 over 2, comma, radical 2 over 2, and that's your terminal point. So for a lot of these here, you're going to find the terminal point of each one. So now, example 4. So t equals negative radians over 4. Let's go ahead and convert this 2 degrees. So negative 180 over 4, and you get negative 45 degrees. So now, in your graph, you have to keep in mind it's negative, so it's working the opposite direction. So if you start at 0, 45 is just about, oops, looking at backwards, is about right here. So it's like 2 units up. So that means you have to work backwards. So instead of going upward, you're gonna go downward. So if it's 2 lines upward for 45, it's going to be the same exact thing with going the opposite direction. So it's going to be 2 lines downward. So that means another angle for negative 45 degrees is also 315. So remember, we can find that just by adding 360 from yesterday's lesson or subtracting 360. In this case, if we add 360 to negative 45, you will end up with 315. So you can do it 2 ways, just counting the number of lines or doing the math by adding or subtracting by 360. So now we have negative 45 degrees. If we look at negative 45, it also goes hand in hand with 315 degrees. And if you look at the coordinates right there for 315 degrees, right there, you get radical 2 over 2, comma, negative radical 2 over 2. And that will be your terminal point. So that's considered that point that you need. B, 3 radians over 4. So let's go ahead and convert this to degrees. So 3 times 180 divided by 4, and we end up with 135 degrees. It's positive, so that means we can just look at this, and just by looking at it, 135 degrees gives us this point right here. And later on, we're going to discuss how and why they got those coordinates. But just for now, we're going to go ahead and just simply put for 135 degrees, we're going to look at the coordinates. And the coordinates for that is negative radical 2 over 2, comma, positive radical 2 over 2. So the negatives and positives, you do have to be very careful with them. Third one, t equals negative 5 radians over 6. We are going to convert this to degrees. So it's negative 5 times 180 divided by 6. And we do the math, grab a calculator, and then you get negative 150 degrees. So instead of working up your way upwards, you're gonna work backwards. So a trick I like to do, either you can add 360 and find that point that also matches up to, or you can simply look at the 150, and it looks like it's 1 point away from one of the 2 lines here. So it's 1 line away from here. So I know if I'm going this direction here, it's 1 line away. So it's going to be in reference to 210. So I mean, another one for -150 is 210. You can also subtract, or you can add 360 into -150, and you'll also get 210. So for the points for 210, that would be negative radical 3 over 2 and negative 1 over 2. So again, it's just by looking at the points here, or you can just add 360 for the negatives. So in this case here, add 360 and you end up with a different number, a positive number, so you can check the points there. So example 4, on your homework, you're gonna have stuff like this. Example 5. So example 5, they want us to do something slightly different. Is finding, sorry, let me turn there. You're finding the reference number. So reference number, they like to use a T and a line over it. So you'll see that a lot. Finding the reference number. So again, we are going to convert all of these into degrees. So that means 5 times 180 divided by 6. And I get 150. To find the reference number, it's just like what we did on yesterday's lesson. We're trying to find whichever, so 150 will be right here. We're trying to see the other side. You're trying to find the other angle, the opposite, the one that's next to it. So in this case, it's this angle right here. So we're gonna try to find that measurement, and we did that before. So all we do is simply subtract by the nearest points here. So the 2 options are subtracting by 180 or 360. It's only the 2 points on the side. So we're gonna do 180 minus 150, and we get 30 degrees. And that will be the reference point. So it's a line and it's a T, and that's what you see in your book. B, we are going to convert this to degrees. And when we do, 7 times 180 divided by 4, we end up with 315. Let me check if that's correct. And then, yep. And that means here for B, we have 315. If you look at your chart, 315 is somewhere around here. I'm just gonna go ahead and draw it here. It looks like it's right there. So we're trying to find the terminal point. We're trying to find this side right there. So to try to find that side, we're gonna try to see, we're gonna subtract 315 from a number, whichever side it belongs to here. So one of the 2 numbers here, the 180 or the 360. In your book, they use radians and 2 radians, but we're just gonna convert everything to degrees. So in this case, we're trying to find the other side, and it's closer to the 360 mark. So we subtract the 2, and you end up with 45 degrees. So that means your your reference number is 45 degrees. Let's do C. Negative 2 radians over 3, negative 2 times 180 divided by 3. Go ahead and do the math there, and you get negative 120. Negative 120, if I were to draw it, will be something like over there. Keep in mind, all reference numbers, they have to be positive, and they have to be between 0 and 90. So they're positive numbers, and it's between 0 and 90. So in this case here, for negative 120, I also know that just by looking here, 120, so it looks like it's 1, 2, 3 units away from here. So that means the reference number would be 1, 2, 3, would be 240. Another way you can find that out is just simply by adding 360 into negative 120. So if you do negative 120 plus 360, you still end up with 240 here. But for me, make it easier, just counting the number of lines there. So here I have 240. I'm trying to find this angle right here, this side over here. So I'm actually going to use that positive number, 240, and I'm going to be subtracting from the 180. Why? If you do negative 120 minus 180, you're going to get a negative number, or 180 minus negative 120, you end up adding it in the end. So we're trying to get a number between 0 and 90. And it also has to be positive. So now we subtract the 2 and we end up with 60 degrees. So your terminal point is 60 degrees. The last one is D. This says 5.80, but it's not like how we typically see 5.80 like a decimal. This is considered radians. So if I were to draw a line here, so just like our units are here, I'm gonna draw a circle. If I go here, I start at 0. I go here, this is 1/2. If I keep on going, this is 1. And it's all in terms of radians. So I start with 0, half a radian, 1 radian, 1.5 radians, 2 radians, 2.5 radians, gonna use decimals now, 3 radians, 3.5 radians, and then this is 4 radians, and I can keep on going, 4.5 radians, 5 radians, 5.5 radians, and this will be 6 radians. So if I see this number 5.8, this is actually in terms of radians. So here, I recommend you using a calculator here for this because also it's 5.8. If I look at this here, I have 5.5 and I have 6. So it looks like 5.8 is probably somewhere around here. Again, remember, we're going around and around, we went around 3 times. So we went all the way around here. So 5.8 is just about there, but we're not gonna get a definite answer. So the best way you can do it is you're going to go on your calculator. You're gonna go to hit degree. So the degree is right there. And there is the radians button, RAD, rad. So you hit that button there. So you do 2 radians. So 2 times radians because we went around once, twice, and 3. So we're gonna do the 2 radians, what we originally started with. 2, that pi turns into radians when you put in radians form. So 2 radians, and then we are going to subtract it from the 5.8. And if you subtract it, you get about this number, 4.8, blah, 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 blah. So it's an estimate because we're trying to find this number here. Again, reference number is just whatever that other angle is, the other side of the angle, whatever is closer to this horizontal line. So that means our answer, our terminal point for this will be about 4.8. They round to the next 2 decimal places. So we're gonna finish the last 2 examples tomorrow, so make sure you keep on watching. Thank you. If you have any questions, go ahead and email me.